Next one, guys. Right, this is a little bit difficult. So let's start. We've got to find the nth term, yeah? So the difference between these numbers. Yeah. So I've got the difference being 6, 6, 6, 6. Good. That means it's a nice linear sequence. So it's going to be 6n plus 1. Yeah, because 6n plus 1 is 7. So we've got to prove that the difference between the squares of any two terms of the sequence is always a multiple of 4. So 6n plus 1 squared. And I've got to do it again. But I can't use n. I've got to use a different variable. Yeah, because if I use n, I'm using like the same term of each sequences. And then we just got to expand them and then see what happens. So 6 times 6 is 36. So I've got 36n squared plus 12n plus 1 minus exactly the same, just with an m. 36m squared plus 12m plus 1. Okay. Always put in the brackets because people tend to ignore that minus sign. Yeah. Let's remove the brackets. I've got 36n squared plus 12n plus 1 minus 36m squared minus 12m plus 1. The nice thing is these two ones cancel out. Okay. So I've got this. And then normally what we try to do is try and factorise our 24. But we can't factorise out 24. So let's try and factorise the biggest number we can do, which actually happens to be 12. Yeah. So 12 goes into 36 3 times. So I've got 3n squared plus n minus 3m squared minus m. So I know that this now is a multiple of 12, but then that's not 24. Yeah. So you've got to think, I need to prove something else. So this little bit in the middle, if I can prove that's even, then it has to be a multiple of 24 because that's a multiple of 2 and the other side's a multiple of 24. Now we can't factorise 2 out, so we can't prove it's even that way, but we can do it even by, it's called exhaustion. And essentially we do like if n is even and m is even. What we've got 3n squared. Yeah, so like 3, I'm going to put even squared, plus even, minus 3 even squared, so minus even. Right, so an even squared has to be an even. Yep, because it's a fact, but then an even times an odd is also an even. So this turns to be an even. Minus an even, and minus an even. So this means that answer has to be even. But then we have to do like every single possibility. So let's do if. So like if, I'm going to rub out some of this actually because I've run out of space. Right, so let's do if n is even and m equals odd. Okay, so I've got 3 even squared plus even minus 3 odd squared minus odd. Yeah. As stated, even squared is even, and 3 lots of it is still staying as even. Right. Odd squared is always going to be odd. Yeah. Yeah. And if I times that by an odd again, yeah, that stays as odd. So it's going to be minus odd and minus odd. Okay. These will be an even. Now, an odd number minus an odd number is still an even number. Yeah. So like 7 minus 3 is 4. Yeah. Yeah. So I've got even minus an even, so it's got to be answer is even. Okay. Still got a few more to do. So I've done even, even, odd. So I have to do if n equals odd and m equals odd. So I've got 3 odd squared plus odd minus 3 odd squared minus odd. Okay. So this is odd plus odd minus odd minus odd. Now odd plus odd is even. And odd minus odd is even. So then I've got answer is even. And last one, I'm really running out of space, sorry about this. I'll do it there. So I've done even, odd, odd, so I need to do odd, even. So if n is odd, m is even. So what have I got? I've got 3 odd squared plus odd minus 3 even squared minus even. Odd squared is odd plus odd minus even, so even minus even. Odd plus odd is even, and even plus even is even. So that's also even. Okay, so I've sort of done every single possible example there. There is no other situation in the world between n and m's which wouldn't result in an even number. And then I'd write a sentence like, therefore, this has got to be even, or a multiple of 2. And then 2 times 12 gives you your 24.